When we're solving a problem involving proportional quantities, we are often given information about a unit ratio. For example, Brian drives a car that gets 23 miles per gallon. This phrasing, miles per gallon, is our clue that we're dealing with a unit ratio, right? The word per in a unit tells us that we're describing a unit ratio, right? This means 23 miles for every 1 gallon. And then we're asked a question about one of the quantities. We might want to know, how far can Brian drive on 20 gallons of gas? Or how much gas does he use driving 150 miles? Now, how do we figure this out? What do we do with that 23 miles per gallon? Do we multiply? Do we divide? Do we do some other arithmetic? The purpose of algebra is to give us a structure that tells us what arithmetic we ought to do. So let's use algebra to figure out how to solve these problems. Let's forget about these specific questions for a moment and think about how we understand 23 miles per gallon. 23 miles per gallon is a unit ratio. You can tell from the word per between miles and gallons. It corresponds to a ratio, 23 miles over 1 gallon. When we start with a unit ratio, we can always write a ratio with the unit ratio as the number in the numerator and 1 as the number in the denominator. So here, once we started with a unit ratio, we can always write 1 in the denominator. Okay, but we know how ratios work, right? The ratio of miles to gallons is what you need to multiply the number of gallons by to get the number of miles. So we can think of this as giving us a formula, an equation, that says m, the number of miles, is 23 over 1 times g, the number of gallons. 23 over 1, I'm not going to write it that way, I'm just going to write it as the number 23. M, the number of miles, equals 23 times the number of gallons. What was the purpose of this analysis? This analysis tells us what order m and g ought to come in. Whatever quantity we have in the numerator of the ratio is what's on the left-hand side of the equation. Whatever quantity we have in the denominator of the ratio is what the ratio will be multiplied by. Okay, this is pretty cool, right? M equals 23 times g. Let's take this back up to our actual questions. So, if Brian uses 20 gallons of gas, that's a value for g. That tells us g equals 20. I plug that into my equation and I get m equals 23 times 20. Okay, that's easy, right? No algebra involved, just arithmetic. 23 times 20 is 460. So Brian can drive 460 miles. Now in the second question, we're not given a value of g, right? We're given a distance. We're given a value of m. m equals 165. Plugging that into our equation, we get 165 equals 23 times g. But not to worry, we still know how to solve that. We'll multiply both sides by 1/23. So let's see. 1/23 times 23 is just 1. Here we're going to get our g. 1/23 times 165. Some horrible decimal. It's going to be 7 and a fraction. Take off the 7, convert the result to a fraction. 7 and 4/23. So Brian uses 7 and 4/23 gallons of gas. Okay, how did we approach this problem? There were really two phases of this problem. First, we spent some time analyzing the ratio, and the result of that analysis was this equation m equals 23g. It was an equation relating two quantities, miles driven and gas used. Once we had that equation, we had to decide which one of the quantities we'd been given, and then plug in the given quantity to find the other quantity, right? Which may or may not involve algebra, right? Here, finding the other quantity didn't use any algebra. Here, we had to solve a linear equation. And finally, we weren't done after we were done with all the computations. We had to give an answer to the question.